Hi everyone, this is a socket coding on Mac platforms. Let me first explain how the program can work. I'm going to give you a demo. The client and server programs in two different protocols, UDP and TCP. The code that you can see here, that is the UDP server program using a function. So on this function, all the procedures of what the UDP server needs to be configured. It uses, because this is a UDP server, the socket is created for the family of sock DRAM. And then that socket needs to bind the IP address and port number. This is a port number that this server needs to open. This is the IP address of the client that you want to receive. If we have only the blank, then this UDP server wants to receive from any server. And then print statements here to see whether the UDP server is ready. This server continues. First, the server socket needs to receive, and then this receive from function returns the message and address. This address is a tuple format of the IP and port numbers about the client. So that message first needs to decode. When any messages needs to send out, then needs to encode. And when the message receives and to display render, then we need to decode it. So decode, and then we can take a look. The message itself, and then first element of that address, that is IP address, and the port number. The second item in this address is port number. The first we want to say we received it, the messages. And then if we want to, then we can reply back to the client. Only we change the message to uppercase. All right. And then we send. We means the socket itself send out. This function is called by sending the port number. So UDP server is now open and bind of this IP and port number. Therefore, the client program needs to use the same port. The client use the same socket, because if it is a UDP communication, then UDP socket for server, UDP socket for client. And we want to do while loop. So say the variable stop initially false. If it is not false, of course it is not, because stop is false. If we say not stop means that is true. So while true, so initially it's true. And then this client needs to talk to the server first. So write a message to server, or type, if stop means it's quit. Okay. If it is a stop, then we need to change this stop variable to true. Therefore, it doesn't go into the else statements. If it is not stop, then we need to user input needs to be encoded and send. Encode and send. Send where? This send to from the socket, client socket, needs the data, and the second element here, second parameter, needs to be the address and port number. So local host and port number. Okay. So send out. And then wait if this guy receives any. Okay. So client socket waits any message from the server. So receive from returns the message itself and the server information. So server has two elemental in tuple, as we looked at on the server side. Server has the address here, that is the client address. At the client side, server means, yeah, this address is a server address. So the first element in this server is a server IP, and the second element is a server or port number, and this is the data. So when a client receives data from the server, then it needs to decode to read. Okay. All right. So how I can demonstrate this? We need to start with the client. From the Windows, client can be, oops. Okay. So holding down command button and hit spacebar. There, if we put terminal, the terminal comes up. Okay. At least you need to have one terminal for server and one or more terminals from the client. So open up the server, and then there is a shell menu. There you need to create new windows for basic. So let's say this is a server program, server. This is a server. This terminal is a server, and this terminal is a client. Okay. I want to put this side by side. All right. So where is the location for this? Get the copy path and come here. This is file itself, so we need to go to that. So change directory to that place. Same thing for on the other terminal. And there is also the location. This location that we the server needs to first ready to serve, right? Server program here, Python UDP server. I'm using function and then py, and then as you can see here, UDP server is ready to serve. That is what this, right? And this UDP server now waits to receive data from the client. So we need to start the client. Python, same thing, UDP client func.py, and it says write a message. So I can say hello UDP server, and then at the server side, server received hello UDP server from 127.0.0.1 colon 51110. This is a server port. Okay. At the server side, server doesn't do anything here, and it sent back to the client. Here, 3 less than sign, and then what is it? Processed by UDP server. Hello UDP server. The message originally sent from client is not all uppercase, but it went to the server and replied from server. It changed to all uppercase. That is here, right? Message changed to uppercase. And that's from 127.0.0.1, and port number, this is a server port. Server opened what port? 53535. This is a server port, and this is a client port. And client still say it works well, and it goes to, it says the server received, it works well from the client, and immediately it returned back to the client. So client immediately received less than triple less than sign, and then processed on UDP server. It works well in all uppercase from this port. This is server port. Okay, this continues until this guy says stop. If I say stop here, then it stopped, right? At the server side, this guy does not know. This guy still waits, right? So what we can do, at the TCP side, I improved this a little bit, so you may be able to see it. But server stopped. I mean, the client stopped. Server is still waiting, right? So if I redo this, then server still waits, and then you can say hello again. Then it says hello again. At this time, the client port number is not the same as before, right? This is right. So it came back, and if I say stop, it stops at the client side, but server still runs on, right? Because we didn't do anything here. In this case, we need to interrupt it, right? Control and C. Control and C, that is the interruptions. So interrupt, that way it stops. So now both are stopped, right? So I want to clear this terminal. Clear, then it clear the terminals. Okay. Now we move to the TCP. TCP server in function, definition and function call, and TCP client function definition and function call. First, TCP server. Server received the port, and then the socket needs to be defined. We call it S, and then that socket binds. Again, it opens from any IP, but this server socket bind it to my port number. What port number? The server port number, 20560. Okay, and then this server listen, and when there is a request from the client, TCP client, and accept it, As it accepts, connection is established. So connection, and then there is a client address. In the earlier UDP case, we say that is only address, and then we split it, the first element and second element as we need. But in this case, as we receive, we receive it separately. That's fine, right? Either way, this is another technique. So we receive the connection. This is a client IP. This is a client port number. And then we write it here, now connected. And then we have a while loop. While loop continues. And then this connection, now connection, right? Not the socket itself. This connection, because TCP is a connection based. Connection receives RCV, which is not the same as the UDP. UDP, socket itself, receive. The language is not the same, right? Not RCV, but RCV from. That is the case of UDP. This is case of RCV is case of TCP. Connection itself needs to receive from that port. And then that is the data. We need to decode it to display. So we decode it and display here the print statements. First, if there is no data, which means client does not send, then we can say, hey, bye, and then break. And if server communicate to the client, this is a mutual interaction. This is another example, right? UDP case, server simply change the client message to uppercase and ship it out. But UDP case, TCP case, in this example, we ask server to enter. There's another input function. So that will be the reply. So reply and the message from the client itself together. And it says the server reply to whatever the client message, colon. This is a server reply. All together encode and send it to the TCP client. TCP client, same thing. It needs to create a socket in the same family, sock stream, like server, TCP server, sock stream. And then connect. Remember, the TCP is a connection based. So when TCP client needs to connect, it uses IP address and port number. Port number, that is the same port number that TCP server opened and bind. So use that. And then while loop, like the other, the client side of UDP, we set up the variable stop and initially false. This is another case. Stay alive and initially is set to 1. 1 means true, 0 means false. So this is another technique that I demonstrate. And while stay alive, and then the client write something or say stop to quit. If it is a stop, then this stay alive equals 0. So it'll stop. This client will stop. Otherwise, client send the message by encoding it. As it sends out, and client now wait some reply from server. Okay, and S means this is a socket, right? and then when data comes from the server, and then print it. Okay, so we'll demonstrate it here. Now we'll do the same thing, same as we do, but it should be TCP server. So I am start the server first. Yeah, the server is waits. It's not yet connected, right? It connects only the client wants to connect. So TCP client. So when I launch client, then then server recognize it, and then connection message there. Oops. What happens? This is not started. Python TCP server funked up. Oh yeah, it was not started. Right now my eyes, it's not. My vision is so weak. I didn't wear my glasses, so I'm not able to see it. Okay, the client. Okay, client. Now this server seems to run. There's no error messages, and still wait if any client comes here. So now this is a client program. As we hit this, then this guy says, okay, connected by, this is a client, still on the same local host, 52027. This is the port number of this client. Okay, and this client, server, is waits any message from the client. So we can say here at the client side, hello TCP server, and then here received from a client. What client? So local and this port. Hello TCP server, right? And then we can say, how are you, client 52027, right? 52027. And it says received from that, reply from TCP server. That is how are you, client that port number. This is how you can practice. All right. Hi everyone. Um, this module is to give you a coding, a client server on the Windows platforms. Client server can be built on Windows for two protocols. So we are going to see the implementation issues for UDP protocols and TCP protocols. Okay, this is the codings for UDP server. I'm using a function definition. So we define a function, and then here's a function call. This function UDP server receives a port number, and the first thing that we need to do is to define a socket, and we call that S. The families of sockets for UDP, there's a sock, DRAM, and then that socket needs to bind um, uh, from the IP, client IP, to the server port. Okay, client IP is now blank, which means any client can connect to this server port. And when any port with a specific port with specific port for any client IP is ready, bind, then there's a message. UDP server is ready to serve. And then we have while loop. This while loop goes forever. While one means true, so it always true. So inside of this while loop runs always. First, this UDP server socket receives the data from the client, and this received from function returns two data. The first element is the message, and then second one is address. This address also has two data components. First one is the IP, the client IP, and the second element in this, the second address, second element in this address, that is a port number. So we can say server received some data from this is IP address, colon, and port number. Then you can see it when this program runs. And the message, the first element, first return data from the received from function. That is that should be decoded in order to display. Nice. And then this the server bounce back to the client with the message a little bit of the modifications. So we put some of the message from the server. This is message followed by the client message that we received. That is turned to the uppercase, all uppercase, and send it back to the address. This is the address of the client address, right? So we send it back to the client. That's what this server can do. On the other hand, this client, UDP client, again, this is a function. This is a function call. This function receives port number. So with that port, first socket is created. So we have a socket, client socket variable. And then we define another variable, stop, initially false, and then while loop. In order to run this while loop, this should be true, right? For stop itself false. If we negate it, then not stop means true. So this while loop true continue to work unless this stop variable changes. So initially, this client get the message from the user or stop if client wants to stop it. So stop, if the user input is a stop, then we change it to true. If stop becomes true, on this while loop condition, it negated, therefore it will be false. That is point this while loop stops. Otherwise, client send user input data to send out, by encoding it. In order to send out through the internet, yeah, from your Python code, then you need to encode the message. When the Python code receives data from the internet and to display, then decode it. And this send to function needs two variables, message and the address to the server. Server IP still localhost, and then the port number is the server port. And then this client, as this client send out the message, this client waits if there is any message from the client. Okay, this server from that's the same function that we received from at the server side. This is receive from function returns the message and address. Same thing at the client. This returns a message and address. The server means this is server address, server IP, and server port number. And the data, so whatever the message from the server, that is written, display after decoded, followed by server IP and server port number. All right. So we need to run this. This is the same code that you can find the Mac demonstrations. So we need to bring up two terminals. So the way that you can bring up on Windows, holding down Windows button and press Alt. There you type CMD for command, and hit OK button. Then I have this. I want to get a little smaller. Okay, I can make it one more terminal. So this terminal will be, yeah, this is client. All right. This guy is here. This is the program that we looked at, right? UDP server and UDP client. So click this, and then Control C to copy. And back here, we need to change directory, cd, and paste to that directory. Same thing here, cd, and change directory. So we both client to server at the same directory where there are client program and server program. So we run the server. So Python and then UDP server func. This server program written using function definition and function calls and py. And then UDP server is ready to serve. And now at the client side, you can do Python UDP client func.py. Then this guy says write a message. So we can say hello UDP server, and UDP server receives, right? Receives, this is client message from the client. Client port number is 61520. Immediately this guy changed this to uppercase, all uppercase, bounce to the client. So at the client side, hello UDP, all uppercase, and this is a server information. 53535. Okay, this is a server port number. This is a client port number. At this client, we can say hello UDP server, and Good to meet you. What happened? Unable to complete back. This guy is doing something. Wait for. I do not want. This guy is so busy. The window. Window is always the issue. So wait. I want to close this and redo. Still, let me check. Task manager. CPU runs so desktop Windows manager. Windows so ridiculous management. But anyway, let's redo. Uh, Hopefully it runs well now. Um, really bad. Okay, see. I want to run this real quick to avoid any system issues. I want to type that and wait. And then here, Python UDP client py. And I want to hit enter, This is a client and all cap. And here, good to meet you, and come back. Good to meet you. And I want to stop it to avoid. And this, unlike uh, the Mac version, this guy server on this local machine is still done. Uh, if we interrupt it, interrupt is not really taken. Uh, this Windows systems, so you can simply um, close the terminal itself. And I want to leave this client version. So point here is that you need to take care of here uh, the client side like here TCP. Okay, what happens here on TCP? Same thing. This is a function definition and function calls, and for the port number and function TCP needs a different the socket type. So sock stream. So socket is created for the server, and server binds the port, same as explained for UDP side. But difference here at the TCP, the socket will listen, and as it listens, if there is a the client uh, messages, then this socket accepts the client messages and returns. This accept returns two things: connection objects and then client address. Address is IP address. Client address is nothing but client IP address and port number. Client port number. We simply write it here. Display connected by client host and client port. And here again, the while loop. Number one means this runs forever, continues, like our UDP while once, right? And this guy now get the data from the client. And if there is no data, then we can say, hey, bye, and then we break this connection. And therefore, this TCP server can be safely discontinued so that your terminal will be okay. It's not stopped at all. Otherwise, we can print uh, the message from the client. Okay, this message from client already decoded, so we display it, and then we can re-ask to the server if there is any message to client, and then reply that once encode to send the back to the client. So server reply to this data. Data means client data. So server replies to the client data colon followed by server message. So kind of a server answer, right? So this while loop at server side a little bit controlled, unlike that we had here on UDP side. It's a little bit of improvement. This is the way that you can learn. And then client side, um, same thing. Function defined and function can be invoked. With the port number, same socket family, socket type to create a socket for the client. And this client socket needs to connect to the server IP and server port. So this server port 20560 should be the server port that server designates. Otherwise, it goes to different ports. Okay. Stay alive. like a stop in the UDP side. And initially equals 1 means stay alive, true. UDP client, the variable stop initially set to false. And in this while loop, the while loop condition should negate it, and therefore it goes uh, uh, in action. Here, because this is true, we don't need to negate it, simply while. This is nothing but while number 1. So while continues. This client, TCP client, we can ask the message, and if there is a message stop, then we turn to this false. So 1 means true and 0 means false. So it'll be false, the while loop stops. Otherwise, we decode the server data. We wait a minute. This is a client message to server. So in order to send it, we need to encode it and send. After the client send message to server, client waits to receive data from server. This receives and returns data, and that's displays. Okay. So we want to demonstrate this TCP. Right now we have only one terminal here. So I want to clear this and open up another terminal. And then CD, let me see if we have still this, the path data buffer. No, it's not there. So we will, or we can get this data if we want. Copy path. And yeah, Python. Okay. So we have the same directory. Okay, Python TCP server func.py. And here Python TCP client func.py. So I'm going to run the server first. Server needs to wait. Server doesn't have any message, as we say here. So doesn't have any message. Server first, the message that we can see here when server client wants to connect. And after it connects, there's a message. Right now, there's no clients. So if this clients activate, then we will see the message here. So enter, and then it's just connected by. This is the same local host, and this is the port number from the client. So this client port number is 53067. Okay, and then we can say here, hello TCP server. Then it says, here's a message from the client, hello TCP server, right? And then the server also wants to talk to the client. Then we can say, how are you, client? Then return from the server is a hello TCP server. Oh, this is my message, right? To my message, the reply from the server is good. How are you, client? So that we can say back to the client, I have a question, and then Here is the message from the client, and then we can say, tell me. Then we can say here, what is it, TCP? And you can say, oh, it is a um, network protocol based on connection. And if we say, then we can say stop if you want to stop it. As we stop, watch this server also will stop because there is no data comes in. Then this server is not hung like UDP code, the case that we gave them a minute ago. This will stop immediately. So both terminal will be okay. Watch this, right? So this terminal okay, and this terminal okay. So I want you to see the code, a little bit of the improvement, the code from UDP to TCP. This is a code issue, not the protocol issue. All right. Okay. Thank you. Here is the Mac book that you can see. This is a Mac. And then we have here Windows. Okay. This is a Windows systems. I'm going to run the client on, I'm sorry, the server running on Mac. I'm going to choose only one protocol, TCP. Okay, TCP protocol. The server is going to set up and run on Mac, and then TCP client will be set up and running on Windows. Okay, so first thing that we need to do is to find out the IP address. Assumption here is both the server and client right now are not having public IP address. So both are running under the same router, so that we can get the IP address for each Windows systems and Mac. Okay, how can you get? Here's you need to get config. If it is Linux, then there is a new version of the command called IP, and then address. Then you can get IP address. But this is a little bit old ones. So you, the command is ifconfig. So if you put ifconfig and then choose the IP that you think it'll be for you. Right now, try to find out. Here, EN0. Then there is a 168.168.101. Similarly, here's Windows. on Windows, you need to type ipconfig. If it's ipconfig, then you can get the IP address for this. Here, wireless LAN adapter Wi-Fi. So that is 192.168.68.129. So now you can see clearly they are under the same router. So this client, first of all, this MAC IP should be addressed on the client program. So back here on Windows, I already got here TCP IP address 192.168.68.101. This port number remains the same as previous. And then this function, I added more server IP and port. And this TCP server, this is TCP client. This client has a server IP. This server IP and then the server port needs to be connected by this client. So this server is 192.168.101, and the port number is nothing but 10560. So client is done. Back here, on here the server, TCP server, I'm going to open the client IP. So quote and unquote, there's no space in between. Quote and unquote, no space in between. Only the port number. And all others remain the same as before. Okay, so I am going to run that server program here. So what I am going to do is Python, and then the server program is TCP server func, and then I put for all.py. This is a server program. So now server program is running. Okay. And back here on my video, now server program is running. This is server program, right? Server program is running. All right. And then I'm going to launch the client on Windows. Here, Python, TCP, client func to mac.py. See on Windows, there's a program, right? Program. It's running on. So I'm going to hit enter. Windows. And what happens? Then I have this on client. It says, what do you want to say? Stop to quit. That's the client side. Right now on Mac should respond. Mac says created by 192.168.68.129. So that is the client right now, right? So I'm going to type on the Hey Mac TCP. I type Hey Mac TCP. So at the server right now, um, any reply to attach it to the client, any reply attached to client, one before the line says here received from a client, hey Mac TCP, right? That's what Mac typed. And then this server now will say, uh, good to see you, Windows. Okay, I want to put here Windows client. See here, I said, good to see you, Windows client, right? So if I hit enter and back here on Windows, it says returned from server. Server reply to hey Mac TCP. So there's my server reply to hey Mac TCP. So there's my right. I wrote that. A client wrote that, and then the reply from the server was good to see you, Windows client, right? So at this point, if client stop the communication, then type stop. Enter. So that's done. And when it comes here, the server says bye, and it is done. All right. What is the point? And Mac, our platform, um, is good for running, good to run the server programs. Windows cannot run the server programs unless we do some additional features installed. Windows by nature is a good platform for client. So we use Windows as client and Mac as a server. Uh, then server may respond it. So you can practice that, and also the similar things can be done over different devices, not only on the same platform, but you can build the TCP server on separate Linux operating systems or Mac OS. Meanwhile, you can also run the client on your Windows operating systems. By the way, Windows operating systems cannot run the server programs. One of the assumptions for them to talk between the server and client, the server program should have either a static IP address or both client and server programs should be running under the same router. If they are under the same router, which is on the same subnet, then they can identify which one is what. So the IP address can be resolved straightforward. If you want to make a static IP for your server program, then you need to buy it. It's very expensive, so you don't need to. But you can practice it under the same router. So I wanted to follow that and check out the video clips. And this last one is for a little more practical because we are talking about server and client. For one server, there should be multiple client. So client should not hold the communication by itself only, but in it we need to share, right? So how can we make it? So we're going to learn it, all right? So implementation details for that, we need to think the protocols. Are we going to build our client and server running over TCP or UDP? In this, well, as we did both the TCP and UDP, and also on different platforms, that's what we did. So I want you to check out the video clips. But for this ones, as an example, we focus on TCP because TCP is connection oriented. This is a little more complicated, so we will learn that. And also communications, one string of communication at a time. That works for the programs that we learned and we practiced so far. But what if we want to interleaving communication? What that means is that because we have one server, if we have multiple client can talk to, while one connection is established to one client, there should be another connection to be established for another client and another connection for another client. One connection per client. We could have multiple clients, and each of those clients can talk to the server as if that client can talk to the server directly at any time. What that means is that the client should not wait until the other client complete their connection. And if that connection is disconnected, then now it is my turn, and I can hold my connection until I complete it, while many other clients are still waiting behind. That is a single threading. If you want to make multi-threading, then because we make multi-different the strings of communications, each client can talk to the same server at any time as if it is communicating in dedicated way. This is some of the program that we have done, typically as discussed in the past classes. So we build the server. The way that we build the server for TCP protocol, we need to create a socket objects and then bind this socket to a particular IP and port number. And then we can listen. This server needs to listen. We can open up one client. We can open up 5 clients. We can open up 25 clients, depending upon the capabilities of our hardware. And then we have a loop. In this loop, we accept a connection and receiving and sending data continually. So for example, if one client create a socket and try to connect, then this server accepts that connection. And then between this client and this server, sharing data by sending and receiving data. Even if the other client create sockets and try to connect, it maybe connects, but it's not currently connection is now, because this is a connection oriented. So this guy, because it's one single thread is only one available. The client 2 needs to wait. Likely client 3 needs to wait until this connection is complete. Then next connection is activated, and therefore data sharing is possible. This is about single threading. So what it does is that if single thread, only one thread, if there is one connection, that connection needs to be complete, and another connection comes, and that should be complete and disconnected to that connection, and then a new connection is established, and then it goes, because it has only one thread. If we have a multi-thread, then we still have the same code, same data, same file, but only difference here is that we have different sets of registers and stacks. Different registration and stacks. We have separate threads. For the same code, same data, we can have multiple threads. So this can work with the client 1. This thread work with the client 2. This thread work with the client 3. Remember that we learned multiprocessing in operating systems, right? Between this multi-thread and multiprocessing is that, as clearly displayed on this slide, multi-threads established for the same code, same data, same files. Multiprocessing, if we have two different, more than one code data file sets, then still we can make it one single thread like this, right? But in this case, single process. But in the last case here, we could have a multiple process. So one process take care of data, code files, register, and stacks, and the other process take care of different code, different data, and files, register, and stacks. We could have more than one process. Today, what we are going to look at is this multi-threading. We're not considering the multiple processes for the one single processing, but multi-threading. This could be done only by code. By running the same code, we can do this multi-threading. So how it works? We need to have a thread object created. Okay, thread object is created per connection. All right. So it is not only one code per connection, but thread object is per connection, and then that thread starts. So in the same way that we create socket objects binding to IP and port numbers and listening, we accepting connections, then we make a threads. Another connection, then we make another thread. For another connection, we make another threads. For each thread can talk to each different client. This thread talk to client 1. This thread talk to client 2. This thread talk to client 3. So this guy is send and receiving. If this guy still send immediately, then before this guy responding, this guy can receive it. So lots of interleavings possible in this case. So without further ado, we're going to practice it. This is a typical program. So this is a single thread, and this is the TCP server and client, but in single threads. How can we learn? How can we run? How can we execute them? Then we need to turn on the terminal. We need to make another terminal. Shell basic. I want to do two client and one server. Okay. This guy is Let's see, where is this guy is running right now? Then I need to find out. I believe that is in, give me a second. That is here. So I'm going to, this is a TCP single thread PY. So find out the location. So this is the location. I get the path name. Close this and move this away. And what I want to do is I want to do a CD and to that place. I want to make this CD. Change it to a tree. Okay, I have that. Let's make sure that I have that. Okay, I have that. All right, this is a server, so I am running TCP single thread. So TCP is now threading, and this guy, what I want to run is TCP client. TCP class client, Python TCP class client.py. I'm running that, and also I want to do this guy quickly got connected by 127. They are running all the same host, right? We call that local host, and IP is 127.0.0.1, port number 56471. So if I want to do similar things, Python TCP class client, same one. Then this guy didn't respond yet, although I connect, because this is a single thread. So one thread is already held by this client. So if this guy says, what do you want to say? So we can say, hello, my server. Then it says, here received, hello, my server, from this guy, right? And then what do you want to reply back to this client? Port number 56471. That is this guy, right? So I can say, I am good. 56471. I'm good. 56471. And then that message responded to this guy 57471, right? Keep doing this. Although even if this guy says hello port server, although this guy says, because this is a single thread, still that thread is held by this guy. So in this case, this guy says I'm good. So this guy says, I gotta go. Bye. I gotta go. Bye. I gotta go. Simply, I gotta go. Then still that single thread is held by the same connection, D1 connection. So that's still from the same port number, right? What do you want to do? Then it guy says okay. Then okay came here, and then I want to say end. What do you want to say? End to quit. So I say end. So I put here end. It says end. What do you want to say? I want to say, let's say dash dash. Then dash dash. And then this is disconnected. After this is disconnected, then here connected by 56472. So far what we did is 56471, which is this guy. But this guy connection is stopped. Now that is connected by this, right? So originally this guy says hello host server. Finally that message came up because this server now by the single thread, by that thread, connection is established for these port numbers, right? So it says hello host server, and then this guy says fine and new. Now that came over here, right? Find menu. And this guy says end. And this guy says okay. And that is disconnected, and that is still waiting for some others, right? That is end. If you see this code, if there is no further messages comes out, then that is ended. So if we don't wait until this guy make that decision, we need to interrupt it by holding down control button for Windows or command button for macOS, and C for Charlie. Oops. I think it's Control C only. Yeah, Control C. So it is gone. Now, for the same ones, I want to run by this guy, okay? TCP multi-threadings. So what I want to do is, rather than this, TCP multi-threading PY. So that is, so server is now waiting. If you see this code itself, I'm not going to explain this code much because you guys do not know yet how you can make a multi-threading in Python. But I can point out here, for one connection, we need to create a thread object. So threading.thread. There's a thread object, and that object starts. That's what it is. Okay, this is a server side. So server is done that. For client doesn't matter. For the same client, I can do this. For the same client, I can do this. See here, I just connected from two different clients. This server can respond for the two different clients, right? Because this is multi-threading. This thread talk to that guy at the same time, not really at the same time, but in multi-threading, this guy responds to a different connection. So if here in this case it says hello from, we can say this is a second, okay? And then this is a first. If I do this a second, this guy already responded. And then you can say hello from first. Still that is hello from second, and here hello from first, right? Still respond. And if I want to say here, what do you want to say? Because I received this guy from the second. So if I say, hey, this might come to second. So that comes to second, right? And then this guy already asked this guy, right? So that I can say, this might go to first. See, that goes to first. So this multi-threading program can talk to simultaneously more than one connections. Okay, that is a multi-threading. That's what I want to say to you in this video clips. Hope you can understand how it works. Okay, you don't need to worry about this, the coding itself, but how they behaves. All right. When I quit from the first to first, so if I do end, then this guy already knows end. If I do end here again, then this guy already say that. Okay, then this guy stop the communication. If I do okay, then this guy again stop the connection. All right, this is it. Bye. on here the server, TCP server. I'm going to open the client IP. So quote and unquote. There's no space in between. Quote and unquote. No space in between. Only the port number. And all others remain the same as before. Okay, so I am going to run that server program here. So what I am going to do is Python, and then the server program is TCP server func, and then I put for all.py. This is a server program. So now server program is running. Okay. And back here on my video, now server program is running. This is server program, right? Server program is running. All right. And then I'm going to launch the client on Windows. Here, Python, TCP, client func to Mac.py. So I'll show it to you. See on Windows, there's a program, right? Program. It's running on Python TCP client func to Mac py. Okay. So I'm going to hit enter on Windows. And what happens, then I have this on client. It says, what do you want to say? Stop to quit. That's a client side. Right now on Mac should respond. Mac says created by 192.168.68.129. So that is the client right now, right? So I'm going to type on the client, say, hey Mac TCP. I type hey Mac TCP, show it to you. Hey Mac TCP, and then back here, and watch what happens. Okay, I'm going to hit enter and send the data to the server. So at the server right now, any reply to attach it to the client, any reply attached to client, one before the line says here received from a client, hey Mac TCP, right? That's what Mac typed. And then this server now will say good to see you, Windows. Okay, I want to put here Windows client. See here I said good to see you, Windows client, right? So if I hit enter and back here on Windows, it says returned from server. Server reply to hey Mac TCP. So there's my right. I wrote that. A client wrote that, and then the reply from the server was good to see you, Windows client, right? So at this point, if client stop the communication, then type stop, enter. So that's done. And when it comes here, the server says bye, and it is done. All right. So what is the point? And Mac, our platform, is good for running. Good to run the server programs. Windows cannot run the server programs unless we do some additional the features installed. Windows by nature is a good platform for client. So we use Windows as client and Mac as a server to set up the Python the codings. Okay, this is it.